So in this part of the video, we are going to explain how SDN handles congestion and it dynamically routes the network flow path in case of congestion. So for this experiment, we are creating a network topology with 4 hosts and 3 switches in Mininet, and we are using Floodlight OpenFlow controller. This controller is supported by OpenFlow, so we can use this Floodlight controller. So first of all, we need to run the Floodlight controller in the background, so it keeps track of the network. So in this video, we'll run a jar file, Floodlight jar file. This makes the controller up and running. So Floodlight controller also has a UI supported, so we can see a UI page which shows the statistics of the network, for example, such as hosts, active hosts, connections, and the switches. So now we go to the terminal and create a network topology with 4 hosts and 3 switches. We can see the Mininet topology is created and the host switches are created. So now if we go and check in the front end, we can see that there are 3 active switches, 6 connections, and hosts. We can also check the topology in the front end UI. So we can see the topology. There are 4 hosts and 3 switches with 6 connections. We can also see the links, the active hosts. We can see there are 4 running active hosts in the network. And also there are 3 switches. So now we are going to create a video streaming between host 1 and host 2 in the network. And this path will have the congestion. So first of all, let's create the congestion. We'll create a congestion with hping. So this sends a continuous flow of traffic between the host 1 and host 2. So we'll ping host 2 from host 1 on a specific port 5004. So there is continuous traffic going on between H1 and H2. Now open another terminal of H1 and let's stream the video from H1 to H2. So for streaming the video, we are using VLC media player. We can see the host 1, host 2. First of all, let's make a video portal up and listening on host 2. So we have to change the root permissions because VLC media player can't run on root. So we have to change to our user, and we can see that a VLC media player is up and running on host 2 at 5004 port. And we'll stream the video from H1 to H2, host 1 to host 2. For this, we have to go in a similar way. We can stream the video, test video. We'll transmit it in RTP protocol. So we have to add and we have to give the destination address, which is of host 2. And we can see, we'll uncheck this active transcoding and we'll stream the video from host 1 to host 2. And we could see that host 2 is listening and host 2 is receiving the video from host 1. So we'll pause this video for a while. Let's rearrange this so we can have a comparison later. So now we'll have a similar video transmission between host 3 and host 4. Remember that host 3 and host 4 shares a common path with the H1 and H2. So there is a congestion in traffic flow between H3 and H4 as well. But we'll see later in this video how this can be overcome by SDN controller. So we'll have host 4 listening for a video from host 3, and we'll stream the video from host 3 to host 4 as well as we did in the similar way for host 1 and host 2. We'll stream the video from host 3. The same video we'll stream so that we'll have a comparison analysis later. We'll use the RTP protocol for streaming, and we'll give the host address, destination address as host 4. So we can see the video will be streamed from host 3 to host 4. So we'll put this all side by side so we can have a comparison analysis. So the top left one is the host 1 streaming the video to host 2, and top right one is the host 2, and the bottom left one is a host 3, and the bottom right one is a host 4. So there will be videos running between host 1 and host 2 and host 3 and host 4. Also remember there is a congestion of traffic from hping going between host 1 and host 2. So we'll synchronize the video so we can have a comparison analysis. So we'll play the videos from host 1 and host 3. They can be seen in host 2 and host 4 respectively. So we could see the videos are streaming as of now. We'll wait for 5 to 10 seconds so that the congestion will come into play. We can see the congestion. So here in this part of the video, remember the top right one is the host 2, which will have the congestion effect, and bottom right one is the host 4, which also is supposed to have the congestion effect because it is sharing the path with H1 and H2. But our floodlight controller dynamically routes this path and will have this congestion free. So if we see this in the top right corner, we can see a delay of 1 to 2 seconds in the video because H2 and H1 is having traffic and there is a latency in that path. So we can see a delay in the video of 1 to 2 seconds compared to other 3 videos. We have to focus on top right one. That shows the congestion. And from this we can tell that there's a congestion and there's a latency happening between host 1 and host 4, host 1 and host 2, and host 3 and host 4 also supposed to have congestion, but it is dynamically routed by SDN controller, here in our case Floodlight, and this is handling the traffic dynamically. That is the advantage of a software-defined network with the controller. Thank you.